Does PyPy translate itself? Am I getting this straight? Does the PyPy interpreter actually interpret itself and then translate itself? So here's my current understanding. For Python's toolchain involves partially executing the program to be translated to get a sort of preprocessed version to annotate and translate. The PyPy interpreter, running on top of Python, executes to partially interpret itself, at which point it hands control off to its Python half, which performs the translation. If this is true, then this is one of the most mind-bending things I have ever seen.
PyPy's translation process is actually much less conceptually recursive than it sounds. Really all it is a Python program that processes Python function/class/other objects, not Python source code, and outputs C code. But of course it doesn't process just any Python objects, it can only handle particular forms, which are what you get if you write your to-be-translated code in Python. Since the translation toolchain is a Python program, you can run it on top of any Python interpreter, which obviously includes PyPy's Python interpreter. So that's nothing special. Since it translates for Python objects, you can use it to translate PyPy's Python interpreter, which is written in Python. But you can't run it on the translation framework itself, which is not Python. Only PyPy's Python interpreter itself is Python. Things only get interesting because Python code is also Python code, but not the reverse, and because Python doesn't ever really exist in source files, but only in memory inside a working Python process that necessarily includes other non-Python code. There are no pure Python imports or function definitions, for example, because the translator operates on functions that have already been defined and imported. Remember that the translation toolchain operates on in-memory Python code objects. Python's execution model means that these don't exist before some Python code has been running. You can imagine that starting the translation process looks a bit like this, if you highly simplify it. As we all know, just importing main is going to run lots of Python code, including all the other modules my underscore interpreter imports. But the translation process starts analyzing the function object main, it never sees, and doesn't care about, whatever code was executed to come up with main. One way to think of this is that programming in Python means writing a Python program which generates an Python program and then feeds it to the translation process. That's relatively easy to understand and is kind of similar to how many other compilers work. For example, one way to think of programming in C is that you are essentially writing a C preprocessor program that generates a C program, which is then fed to the C compiler. Things only get confusing in the PyPy case because all three components, the Python program which generates the Python program, and the translation process, are loaded into the same Python interpreter. This means it's quite possible to have functions that are Python when called with some arguments and not when called with other arguments, to call helper functions from the translation framework as part of generating your Python program, and lots of other weird things. So the situation gets rather blurry around the edges, and you can't necessarily divide your source lines cleanly into Python to be translated, Python generating my Python program and handing the Python program over to the translation framework. The PyPy interpreter, running on top of Python, executes to partially interpret itself. What I think you're alluding to here is PyPy's use of the flow object space during translation, to do abstract interpretation. Even this isn't as crazy and mind-bending as it seems at first. I'm much less informed about this part of PyPy, but as I understand it, PyPy implements all of the operations of a Python interpreter by delegating them to an object space, which contains an implementation of all the basic built-in operations. But you can plug in different object spaces to get different effects, and so long as they implement the same object space interface, the interpreter will still be able to execute Python code. The Python code objects that the PyPy translation toolchain processes is Python code that could be executed by an interpreter. So PyPy reuses part of their Python interpreter as part of the translation toolchain, by plugging in the flow object space. When executing code with this object space, the interpreter doesn't actually carry out the operations of the code, it instead produces flow graphs, which are analogous to the sorts of intermediate representation used by many other compilers. It's just a simple machine manipulable representation of the code, to be further processed. This is how our Python code objects get turned into the input for the rest of the translation process. Since the usual thing that is translated with the translation process is PyPy's Python interpreter, it indeed interprets itself with the flow object space. But all that really means is that you have a Python program that is processing Python functions, including the ones doing the processing. In itself, it isn't any more mind-bending than applying a decorator to itself, or having a wrapper class wrap an instance of itself, or wrap the class itself. That got a bit rambly. I hope it helps, anyway, and I hope I haven't said anything inaccurate. Please correct me if I have.
Disclaimer: I'm not an expert on PyPy. In particular, I don't understand the details of the Python translation. I'm only citing stuff that I've read before. For a more specific post on how Python translation may work, check out this answer. The answer is, yes, it can, but only after it was first compiled using Python. Longer description. At first it seems highly mind-bending and paradoxical, but once you understand it, it's easy. Check out the answer on Wikipedia. Bootstrapping in program development began during the 1950s when each program was constructed on paper in decimal code or in binary code, bit by bit, ones and zeros, because there was no high-level computer language, no compiler, no assembler, and no linker. A tiny assembler program was hand-coded for a new computer, for example the IBM 650, which converted a few instructions into binary or decimal code, A1. This simple assembler program was then rewritten in its just-defined assembly language but with extensions that would enable the use of some additional mnemonics for more complex operation codes. The process is called software bootstrapping. Basically, you build one tool, say a C++ compiler, in a lower language which has already been made. Everything at one point had to be coded from binary, say ASM. Now that you have C++ in existence, you can now code a C++ compiler in C++, then use the ASM C++ compiler to compile your new one. After you once have your new compiler compiled, you can now use it to compile itself. So basically, make the first computer tool ever by hand coding it, use that interpreter to make another slightly better one, and use that one to make a better one, and eventually you get all the complex software today. Smile. Another interesting case is the CoffeeScript language, which is written in CoffeeScript. Although this use case still requires the use of an external interpreter, namely Node.js. The PyPy interpreter, running on top of Python, executes to partially interpret itself, at which point it hands control off to its repython half, which performs the translation. You can compile PyPy using an already compiled PyPy interpreter, or you can use Python to compile it instead. However, since PyPy has a JIT now, it'll be faster to compile PyPy using itself, rather than Python. PyPy is now faster than Python in most cases.
If you want to see more, please consider subscribing.